into a couple of other topics as I just mute Dr. Bowman for a moment and turn off his webcam so he can go on with his day. So I'm going to now talk a little bit about the value of patent data. And before I get started, I just wanted to take a moment to share with you that we are actually tweeting this conference, this symposium, via the Altmetric Simp hashtag on Twitter. Speaking of, boosting one's signal via social media, you can follow the conversation and kind of back channel with other participants using that particular hashtag. So it's Altmetric Simp SYMP over on Twitter. So anyway, let's go ahead and switch gears a bit to look at one particular type of data. So my role at Altmetric, I'm currently the Director of Research and Education at Altmetric, and the organizer of today's symposium. I do a lot of kind of tracking of the research literature to understand the studies that are being done with our data, so we can kind of get a better sense as to what the value of our data is to the community and help better educate folks on how it should be used. So basically, in the next few minutes, I'm going to be talking about patent data in particular. And Dr. Bowman's talk serves as a really excellent premise to begin to look at particular types of data, because if we understand that Altmetric's data exists within these larger social constructs, like the academic reward system that he was talking about, we can make meaning of it, right? So before we really get started, I'm just going to introduce myself to those who may not know me. So as I mentioned, I'm Stacy Konkiel, Director of Research and Education at Altmetric. What I tend to do beyond just monitoring the research literature and organizing events like this, I also do research, and my research interests include incentive systems in academia and informatics. And I've been writing and presenting widely since about 2013 about altmetrics and open science and library services. And previously I worked with the amazing teams at Impact Story, Indiana University, and the Public Library of Science. So with that out of the way, I want to talk about patents data. So alongside publication and citation data, patents data can be a very useful way to understand how knowledge flows from academia to industry and back again from the university to the economy. So in this talk, I am first going to discuss academia's role in innovation as a partner with industry and government. Then I'm going to look at why patent data can be one of many useful inputs that you can use to understand innovation, and this is due to its purpose and then also certain characteristics of data that we have available around patents. And then finally, I'm going to share a few ways that patent data can be used practically to understand the impacts of one hypothetical study. So this is just going to illustrate the ways in which information about patents, and specifically citations to research from patents, can be used to craft narratives around various types of impact of research, including and beyond economic impacts. But before we really can dig into patent data in depth, we need to take a look at how innovation happens. So what are the larger social forces at play that really drive innovation? One popular theory is the triple helix model of innovation. So it used to be, excuse me, that theorists primarily believed that innovation came from government, because governments put policies into place that incentivize the creation of new knowledge. So for example, the patent system itself is that kind of incentive, whereby people can make money off of their new ideas. A lot of innovation also comes from the military arm of the government, for example, satellite technology. Other theorists, perhaps the Friedman wing of social theorists, believed that innovation was driven primarily by industry. So if you give businesses a financial incentive to create new technologies, by allowing them to profit off of these inventions, often by filing patents and monetizing ideas, then it's industry that's best suited to innovate, because the thinking goes that innovation is able to really flourish when you're free from the bounds of government bureaucracy. We see this play out in the pharmaceutical industry, for example, in new drug discovery. But The triple helix model of innovation is different, and that acknowledges that we now live in a primarily knowledge-based society, and some of our biggest innovations are going to be in realms that aren't exclusively the domain of government or industry. So for example, take quantum computing. So industry is certainly interested in this topic. IBM has been there since the very beginning, helping with a lot of the research that's happening. And they obviously have skin in the game in terms of monetizing this technology. And government wants it because of its military capabilities, including, I should add, teleportation. It's really funny and also super interesting. You should look it up. This is one of the biggest advancements in quantum computing, has to do with teleportation. Anyway, so for the longest time, though, even though industry's been interested and government's been interested, most of the innovation in this area has come from academia, who's not concerned about the practicality or the profit to be made off of this particular area of research. So it's university researchers that are really pushing the frontier. Major breakthroughs have come thanks to researchers at places like UC Santa Barbara and Yale and University of Michigan. But universities do not operate in isolation. They're not in a vacuum, right? So they collaborate with industry, they take funding from government. Researchers also move back and forth between these realms too. And all three parts work together collaboratively to advance knowledge. So that is the triple helix model of innovation in a nutshell. And we're going to come back to this idea in just a moment, but keep this theory in mind. So let's now turn to how we understand innovation in terms of how we measure it. Innovation is not a linear process where you start at point A with an idea and you end up at point B with some new technology that ends up changing the world. Innovation is incremental, it's really back and forth, it's people building off of each other's ideas for years before major breakthroughs happen in a field. One of the best ways that we currently have available to understand innovation is to look at patents. Patents are a form of intellectual property that are managed by the government of various nations throughout the world. And patents provide the patent holder, often the person who invents something or has an idea, with the exclusive right to commercialize an invention for a certain period of time. And in exchange, they give a detailed public disclosure because the idea is that you get to profit now, but eventually society benefits from your idea. So an example would be pharmaceutical companies who file drug patents in the US. They get a certain period of time to make gobs of money off of these amazing new drugs that they're able to develop using their patented formula. But once their patent term expires, other companies can come in and start making generic versions of that drug, which are often sold at a much cheaper price and therefore go on to benefit a broader swath of society. So those who study patents' role in innovation have pointed out some of the following reasons why patents are one good way to understand innovation. So first, they are a direct outcome of the inventive process, and more specifically, of inventions that are expected to have a commercial impact. Second, and kind of related, they're a particularly appropriate indicator for capturing proprietary and competitive dimension of technological change. That is, they help us to understand innovation's potential effects upon the economy. Third, patents are broken down by technical fields, and thus they provide information not only on the rate of invented activity, that is, how often patents are being filed, but also the direction of inventive activity. So by looking at the filings of patents, we can understand new frontiers in technology. But patents are not without their limitations. So one, for example, is that you can't see that a patent's been filed and know that, hey, a major innovation or major breakthrough happened there. And that's because people do not always patent the big idea. Patents are often filed to lay claim to incremental improvements upon existing technologies and the monetization thereof. So it's about fine-tuning an idea rather than major breakthroughs often. Secondly, patents really only look at commercialization and commercializable or monetizable ideas, right? So they're not fully reflective of all knowledge production in an emerging area of research or all fields within academia or knowledge production in general. For example, we're speaking of social theory earlier, the social theorist Foucault, right? Has there been a person who has had a larger impact in many ways upon modern society than his ideas that have kind of trickled out into the world? If Foucault were able to have patented his ideas, I mean, he would have been a very, very wealthy man and potentially more respected, you could argue, in some circles. But he was developing social theories and not widgets, right? So we'd have to look at some other type of data to understand Foucault's effect upon society beyond patents. And so patents are just one type of data that we have to understand innovation. And we should understand also that innovation is very much multifaceted. So all of that said, patent data is an excellent way to understand some aspects of innovation, and that's because of their characteristics. So patents provide longitudinal structured data on collaboration, commercialization, and inventors. Patents have been around for many decades, and so we have a lot of structured data available to work with to understand some of these aspects of development and ideas throughout countries worldwide. Crucially, patents provide structured data on related technologies and research. So this is often called prior art. And it's this last type of data that we at Altmetric are particularly interested in. So patents provide highly structured data that is required when you're filing a patent. And your patents are checked very carefully by people called patent examiners who make sure that you are citing other patents that have to do with the technology that you are filing a patent related to. So it's as if they were a manuscript editor and they were checking to make sure that you are citing every single other article ever published about a topic. That's kind of what patent examiners do. So there's huge amounts of citations to other patents that lots of people have studied over the years in order to understand knowledge flows. Less studied has been citations to research outputs in patents. So we can look to both of these types of data to understand how people stand upon the shoulders of giants, so to speak, in research, and how various parts of the triple helix model interact with each other. So non-patent citations can tell us a great deal about the interplay of the various aspects of the model, right? So industry, government, and academia, influences of public funding in the non-commercial sector, how academia drives industrial innovation, and so on. What's incredible about the bulk of this canonical research in this area is that most of it, this field has really only been around since the 1990s, people studying citations to research from patents called non-patent citations. People have really only been studying this since the 1990s, and it's only very recently that we've been able to automate the process of picking up non-patent citation data so that they can be analyzed at scale. So you'll see a lot of this research is from late 90s, early 2000s when people were doing this manually, which is just mind-blowing. But nonetheless, we know a lot about knowledge flows within academia thanks to non-patent citations. So very briefly, here are 3 ways that you can think about how this type of data might help to build a narrative around the impact of one particular hypothetical study, a malaria vaccine. So in academia, institutions, particularly those who are beholden to national reporting requirements through exercises like the REF or the RAE in Hong Kong and Australia, might want to build impact case studies to know and to communicate to the outside world how their institution's research is making a difference. So obviously, one of the biggest things that you would promote with something like malaria vaccines is pointing to how many lives were saved. Can there be a bigger, more important, broader impact? But it's through the patenting of that vaccine, bringing it to production, that those lives were saved, right? Not just Dr. Turner publishing the article on the vaccine. Governments who often end up funding research want to know, obviously, about the lives saved, but they also want to understand return on investment. So, for example, the NIH might be interested in the impact of their grant dollars in terms of the studies they fund. So one thing that they might report out to their various stakeholders might be that, for every $1 spent funding this particular study, $5 were invested in local economies because it went on to be produced here in the US. And then finally, there's businesses, industry. So pharmaceutical industry, in this particular example, you may or may not know that the pharmaceutical industry actually bankrolls many, many studies that are done by folks working in universities and academia in order to kind of do, let's say, outsource their research and development. They also want to know how the money that they are giving to funded research is making a difference in the world. So they want to know its potential for commercialization. So they might report something like this to their head of research and development. We recently started indexing citations to research from patents within Altmetric. My colleague Jean Liu is going to talk a bit more about this in a few moments in our roadmap update. But yeah, that is, I think, it for me. So I'm happy to take any questions very briefly. Maybe we have time for one question if there are any. Otherwise, we can move on.